I want to go over chapter 8 with you. I want to just talk, I'm not even going to work them all to completion. I'm just going to kind of get your brain going on how you need to do it. Okay. Number 1, this one was a little tricky because we haven't talked about function for a couple of months. So it's in your brain. It's just probably way far back. All right. So it wanted to know first is the relation of function, and then it said explain. That's step 1. This was a 2-step one. How do we tell if something is a function? You guys remember? No cheating. Yes, good. No cheating or no repeating x's. So our x's are good. We had 40, 50, 60, 70. Nobody was repeating. So yes, it's a function because there were no repeating x's. Okay, and I'm just going to kind of abbreviate here. Then there was more to it. It went on to ask, describe how gas mileage is related to speed. So as one changes, how does the other one change? So the first thing you would want to do is you would want to look at how your, remember this is your x and your y. How do your x's change? Well, they go up 10, they go up 10. So they're constant. That's nice, right? But look at your y's. We go down 3, but then we go down 4. So we can't really write a slope because this is not linear, right? We have a change. We have constant on the x, but not constant on the y. So we can't really answer this with a slope or with a rate of change because it's not linear or it's not constant. But what can we say happens? When what happens to the other one? So you just describe it in words, right? And it says describe, so you should think words anyway. So in words, what would you tell me what happens when x does what? What's x do every time? Yes. Yeah. And you could even, in this one, because it's not linear, I don't even care if you put by 10. That's a good detail, but I wouldn't count it off. So when x increases, what does y do? Decreases. That's it. That's all you had to do. You had to describe their relationship, right? As one went up, one went down. That's the relationship. And because it's not linear, if it was linear, if everything here was -3, -3, -3, you could easily do the relationship -3 over 10, right? Because it would be linear or constant, but that doesn't work when it's not. So words work here. Words work good here. All right. So finding the 12th term in the sequence. This should have taken you back to 8-2. Okay. And if you didn't have to go back and look at your notes for this, then you have an amazing memory, because guess who had to go back and look at notes for this? I couldn't remember for the life of me how to do this. Okay. Until I looked at Austin's notes. So you have to, okay, set up your equation, right? Number these, right? We number our terms. 1, 2, 3, 4, right? We look at our common difference. What's the common difference here? +4, right? Do we +4 every time? So it's our common difference. So it's T equals, it's our common difference times N. Does anybody remember what you do at the end? What do I need to do to my first term to make it equal my common difference? What's my first term? 3. What do I need to do to 3 to make it equal 4? Levi? What would I need to do to the number 3 to make it a 4? Yeah, +1. So that's what that is find the, so it says find the 12th term in the sequence. So that is the equation we need. And now to find the 12th term in the equation, where would we plug in 12? What do you think? Yeah, for the n. We want the 12th one. So the term we're looking for is 4 times 12 plus 1. 4 times 12 is 48 plus 1. So our answer here is 49. Okay, but I need to see this work right here in order for the 49 to be a valid answer. All right. Okay, I'm not going to work these. You guys should know how to do these. It says in the directions, find 4 solutions, write your solutions as ordered pairs. So if you did a box or a T-chart, I don't care. It doesn't matter to me which way you did it. But what I would do for the first one, number 3 here, I would do an XY table. Just pick 4. It doesn't matter. 0, 1, 2, 3. There's 4 easy ones. Then work it. Y equals 3 times your first X, which I picked a 0. You may not have the same numbers in there as I do, and that's okay. Equals 0, right? So when I plug a 0 in for X, I get a 0 for Y. Then I would plug in a 1, right? When I plug a 1 in here, I get 3. When I plug a 2 in here, 3 times 2 is 6. When I plug a 3 in here, 3 times 3 is 9. Is that 4 ordered pairs that are solutions to my equation? Yep. So over here, you'd write 0, 0, 1, 3, and so on. Okay. And like I said, you might have picked 4 different ones. That's okay. You had to do the same thing for number 4. I needed a table or a T-chart. Pick 4 X's. Don't care what you picked. Run them through the equation, get their coordinating Y's, write it as ordered pairs. Your answer should be 4 ordered pairs because it says 4 and it says write it as ordered pairs. Same thing for number 5. Does it tell you you have to use 4? So I wouldn't use 4. I'd only use 2 or 3. Okay. Do your T-chart, pick a couple X's that work well with your graph. I would have probably picked -1, 0, 1. Run them through your equation. And if I remember right, yeah, it looked like this. Okay, that's what your graph should have looked like. But just the graph doesn't work without the T-chart and the ordered pairs because you have to plot ordered pairs. All right, skipping down to the next section. Not going to spend a lot of time here. Rate of change, drop 1, right, run 1, right? Rate of change, -1 over 1. Okay. Here you need to look at, these are your X's, these are your Y's. Y's, change in Y over change in X. Okay, that's rate of change. You guys should be pretty good at finding slope. This one I want to slow down just a little bit and talk about because they kind of throw a little bit of a curveball at you. Here's why. Look at your X's. We go +2, we go +2, and then we go +1. Our X's aren't constant. So it kind of was a little weird. You might think, well, it's not linear. How can I find a rate of change? Well, it is linear, and I'll show you why. Look at your Y changes. +14, +14, but then +7. Well, that's okay because when we cut our jump in half, does it make sense that our Y would be cut in half as well? So if you were to, and I did this last hour, if you were to draw a box here and plug in the missing numbers, right? So if this is 0, 1, 2, 3, 4, oh, I got too big. Let's take off 4, make that 2. You don't have to do this on your paper. I'm just showing you why it is the way it is, okay? So I just filled in the blanks because it skipped over 1. I'm just sticking 1 in there. And then we had -20, -6, 8, nope. 8, and then really close here, right? We had 15 because we didn't skip. So these are our X's and our Y's. Well, if this jump is 14 and this jump is 14, and that's a 2 jumper, right? We jumped 2 spots. It would make sense that half of that jump would be 7 because what would this jump be? It'd be 7. So does that make that double jump also 14? So in doing these, what you really need to be careful, look at your X's and make sure, are they constant or is there a skip? Is there a little bit of a difference? If there's a little bit of a difference, look and see if it still makes sense. And I'll show you another way. If you look at this, what's 14 divided by 2? 7. What's 14 divided by 2? 7. What's 7 divided by 1? 7. It still works out. It's still constant. It's still a constant rate of change of 7. Now, like I said, this right here was not required for the work. Okay, that was just me showing you how they skipped a few things. Okay. All right. This one really tripped a lot of people up, and I get it because we really hadn't done a whole lot with it. So number 4 here says that suppose 2 pounds of meat costs $9.50. Well, how much would it, first of all, let's find out what's it cost per pound. Okay, so somebody tell me what they got per pound. Yes, sir. I think it's 75. I think it's, but you're right. You just divide 950 by 2 because 2 pounds is that. So 1 pound is going to equal $4.75. Okay. So if we write an equation for the total cost, right, our final answer, what's our input? Our input is the number of pounds. Well, we use an X for that because we're writing an equation. And then what would we put here? Cost for 1 pound. Now, do I have an equation where if I ask you how much does it cost for 3 pounds, 8 pounds, 20 pounds? Doesn't matter. You just put the input is our X's. Remember that our input is our X, our output is our Y. So our total cost is the Y. The input is what can change. Well, that's how many pounds you buy. So there's your equation. Now I'm not going to work this one. What's the total cost for 5 pounds of meat? Remember, X is your pounds. Okay. All right. I'm not going to spend a whole lot of time on this. You guys know how to find slope with 2 pairs, right? You just use your change in Y over change in X. Okay. This is the only one I'm going to slow down a little bit for. State the slope and the y-intercept. Well, what is the slope? Slope's the M, y-intercept's the B. Right now, I have no idea what those two are because it is not in slope-intercept form. So what should I do? Should I move some things around, Bella? Good. Subtract 3x and subtract 3x. Why do I do that? Well, because I want to write it in y equals mx plus b. That leaves me 6y equals negative 3x minus 6. What then, Bella? Yeah, well, I divide 6 off of everything. Everybody gets it, right? To be fair in math, everybody gets it. So that gives me y equals negative 3 over 6 is negative 1/2. Negative x divided by, or negative 6 divided by 6 is negative 1. Now, the question asked me, this is number 3, the question asked me to state my M and state my B. So my answer needs to be M equals and B equals. Do I now have what it takes to state my M and state my B? Okay, I do. Then you can graph it. Well, it's very easy to graph from right here. Okay, graph it from the equation. Begin by graphing your B. Use your M or your slope to move up and over or down and over. And then the last one, again, I'm not going to work this one. I'm just going to nudge you in the right direction. Write an equation in slope-intercept form. Okay, this is for number 5. To do that, what do I need? I need an M and I need a B, right? I have a bunch of points. Does it matter what 2 I pick? I'd pick the 2 easy ones. I'd pick that point right there and that point right there. I'd do 48 minus 13. That's my change in Y. Over 5 minus 0. That's my change in X. Find your intercept, find your slope. Now, you can then choose a given point, plug into y equals mx plus b, okay? So my slope here that I got was 7, I believe. You do the work on your own. I want to see the work when you do it. Don't just put it, but I think it's 7. I'm going to choose a given point. Let's choose this one. Y is 48 equals my slope times my x that I chose, because I chose this point right here, plus b. 35 plus b minus 35 minus 35, and I get b equals 13. Now I'll show you why I worked this out, okay? So my equation is y equals mx plus b. Now, again, don't just write the answer in there. Do your own work here in a second, but I want to show you something. So I'm going to erase this because I don't want you copying it down. All right, I want to show you something. If I were to ask you, what is the x value of every point on the y-axis, what would you tell me? Let's use this graph as an example. If I were to tell you what's the point, what's that point value, what is it? What's the coordinates of that point? 0, -1. The x goes first. Okay, how about this point right here? What would that one be? 0, -4. Anybody see a pattern? I'm just writing the coordinates of different points I'm picking at random. What's the coordinate of this point right here? 0, 1, right? I don't go over at all. I just go up 1, so I have a 0 for an x. Every y-intercept is going to have a 0 for an x. That's why it's an intercept, because it sits right on the axis. It does not move left or right. Do I have a point with an x of a 0? That right there is your intercept. It's just a shortcut. If you happen to be given the y-intercept, it's kind of like a gift. You don't have to do all the math to find it. You can just look. If you see x of a 0, you know that the y is your intercept. It has to be, because when you graph it, you don't go left or right. You just go straight up to 13. So it's your intercept. Okay, that's a shortcut. If you forget the shortcut, don't worry about it. Do it the mathy way. Okay, all right. If you are done, turn this in. If you are not, keep it and turn it into me either later today or tomorrow. If you turn it into me by the end of the day, it's 4 out of 5. If you turn it into me by the end of, or by tomorrow, it's 3 points out of 5. So, okay, just, I want you to get it done. All right, the next thing I want to do, how are we doing on time? I want to really quickly just go over your Khan Academies, and I mean super quickly here, okay? A couple of you had a few problems with these. I don't think after the jump start, anybody should have a problem with this one, right? You're given 2 points. Yes. What? The Khan Academies? Well, they're technically due for anybody in class. The due date time is always at the beginning of class, but I'm not going to look at these until after school today. So as long as they're done by after school, I'm not going to go back and time check them. But no, I don't want you working on them right now. When everybody close their Chromebooks, and I just want you to listen for a second. I'm not going to do these. I'm just going to really quickly show you a few things. This one, just like our jump start, you should be okay with this by now. 2 points, find your slope, pick a point, plug into y equals mx plus b, blah, blah, blah. Find your b. And then notice they already have y equals. All you have to do is do the mx plus b. Okay, not going to work them. I just want to show you this. The other thing I want to show you is slope, intercept. Looking for something specific. Graphing slope intercept form. All right, when you are graphing slope intercept form from an equation, okay, Khan Academy gives you a couple of points that you need to start dragging around. Austin, up off the wall, please. Khan Academy gives you some points, and when you pick them up, you can just move them wherever you want them. So you always begin with your B, right? And in this case, my B is, I'm not even going to try to use that pencil tool. It messed it up last hour. My B is +8. So I'm going to drag, I'll just move this one out of the way. I'm going to drag this point right up here to +8 on my y-intercept, because I'm going to drop my y-intercept first. I'm going to begin by plotting my y-intercept. Then I'm going to use this one, right, to move where I need to move for my slope. I'm going to go down 4. So 8, 7, 6, 5, 4. That's down 4. And then I'm going to run 3. Nope. Run one more. There we go. And just take a second to glance at it. Did I fall 4 and run 3? In this case, I did. So then you hit check. Okay. Just drag your points around. I wanted to show you that. And then on the other one, I wanted to show you, is this it? We're not going to watch the video, obviously. I just want to find slope intercept equation, writing. Where is it at? From a graph. There we go. These are super easy. Don't overthink this. Okay, where is your B? It's right there at +3. So they already give you a plus sign. Just put a 3 in that box right there. Okay, don't overthink this. Your B is 3, then find your slope. I go up 1, 2, 3 over 1. So my slope is also 3. They give you the y equals, they give you the x plus, you just have to fill it in. If it was a -3, if your B was down here at -3, just put a -3. Now, when you write it for me, you wouldn't write plus or minus, but since Khan Academy stuck the plus sign in there, use it. Okay, you can't change it. So they give you the y equals, they give you the x. This is kind of like in the notes where I left them blank and put lines for you to fill in. Okay. All right. The last thing I want to do is, and we got plenty of time, will you pass these out to everybody on that side of the room, and you pass them out to everybody on this side? You'll have extras. Okay, just send them back down the rows and I want all the extras. All right, the last thing I want to do is this is your actual homework assignment. Okay. So instead of taking notes on this, I want to do the top half of your homework assignment with you, and then the bottom half is for you to do on your own. Okay. Wait till everybody has one, and then we will get rolling. If for some reason you didn't get one, raise your hand. I'll take all the extras. Thank you, thank you, thank you. I appreciate you guys. Everybody get one? Thank you, I appreciate it very much, Lincoln. All right, thank you, Miles. So we are going to work the top half together. Your homework is the bottom half, all right? I will work the top half with you, and then I'll give you a couple little pointers on the bottom half because they're not quite identical, but you have everything you need to do them. All right, so number 1 says make a scatter plot with the data that you're given in the table. So we've done this before, okay? This should be a review, but we are going to take all of the given points from the table and we're going to plot them on here, okay? So the first point is 1980, and remember that's X's and Y's, right? 1980 is your X, and just to be clear here, 1980 is your X, and the average earnings are your Y. So I go over to 1980, and then I go up to 9.94. Now, do I know where 9.94 is? Not to be exact, but do I know it's right under 10? That's close enough for me. Okay, over to 1980, up to 9.9. Then over to 1985. Well, I have to notice that this is 80 and this is 90, so this would be 85. Okay, so I'm going to go over to 1985, and then I'm going to go up to 12.3. Well, again, right, up over to 1985, up to, well, 12 is about halfway between 10 and 15, so I'm good with right there in the middle. Okay, these are going to be guesstimates. They just have to be smart guesstimates. Can't put it up by 20. All right, 1990. So I go over to 1990, and then, right, so here's 1990 right here. And then I'm going to go up. Now, 13.7, going to be a little bit higher than my last point, but not all the way up to 15. So I'm going to just kind of plunk it where I think it might fit. Now I'm going to look at 1995. Again, if this is 90 and this is 2000, this right here has to be the 1990 line. So I'm going to go up to 15.09. Well, that's just almost right at the 15. So just maybe a hair above the line. And then I'm going to go to the year 2000, which is right here. And I'm going to go up to 17.48, which is about 17.5, which is about smack dab in the middle between 15 and 20. And I'm going to put a point there. And then last, I've got 2005, which is halfway between 2000 and 2010. And I'm going to go up to 19.46, which is just shy of 20. And I'm going to put a point there. All right. I have now graphed plotted my data. Now I need to draw a line of best fit, okay, through the data. Now remember, we've done this before. You're going to take a ruler or a pencil or some straight edge, and you're going to kind of play with it and adjust it. And here's the really important part. And if you want to make yourself a note here, it is super important. It has to anchor with 2 points. Okay. It has to, and you have to circle them. Now it's going to be important at the bottom of the homework, and I'll show you why. So I'm going to take my little line tool here. And I'm going to decide that I'm going to anchor, let's make my line blue. I'm going to anchor between this point, and then I can play with it, right? This is my ruler, and I'm kind of moving it around, and I see where does it kind of best go through most of the data, and I have 2 anchor points. Well, I'll pick this, and I'm going to circle my anchor points, right? This is an anchor point, and this, oops, no, let's use the other one. The other one was a better anchor point. There's an anchor point, okay? Those are my anchor points. It's really important, not for this, but for the bottom. And I'll show you why here in a second. So number 1 says make a scatter plot, draw a line of best fit. Have I done that? Okay. This right here, you don't need. I'm just pre-warning you, you're going to need it for the bottom. Use the line of best fit to predict the hourly wage in 2010. Here's 2010. Follow it up. Where does the line cross? Make a prediction. What do you guys think? About halfway between 20 and 25. So what would you say it is? Maybe a little under half? 22 makes sense? Because I'm looking at this point right here. 2010, where does it intersect? I'd call that about 22. Somebody else might call it 23. Somebody else's line of best fit might be a little different, and that's okay, as long as you're not saying 48, okay? That's it for the top half. Plot your data, draw a line of best fit. It has to be anchored between 2 points, okay? I'll show you why it's important. You're going to make yourself a couple of notes here, okay? You are going to make a scatter plot, which means you're going to plot your data. You're going to draw a line of best fit, okay? You are going to anchor it between 2 points. Why? Because when you anchor it between 2 points, your slope, okay, you have to use your anchor points to find your slope. So use 2 anchor points. And what do I mean by anchor points? I mean, all my data didn't sit right on my line of best fit, right? So if I use this point right here and this point right here to find my slope, is it really going to be the slope of the line I drew? No, it would be the slope of this line. See how that's way different? Just 2 anchor points can do that. So that's why you circle your 2 anchor points, because using the correct points to find slope will make all the difference in the world. Okay, so we plot the data, we draw a line of best fit, we use 2 anchor points. Whoops, that got weird. We use 2 anchor points to find the slope. Now, you can use your mathy way of finding your slope or your B, right? I need an M and I need a B to write an equation, right? If I was to ask you what's the B of this, would you have to do any math? What if I kept this line going straight and ask you what the B is? Remember, the B is your y-intercept. So what could you tell me just without doing a single bit of math? What's my B here? What would you guess that to be? About 6? I'd be cool with that. So could I write an equation? Could I now this is not what your line of best fit is going to look like at all. I'm just slapping it on here. But what if this is my line of best fit? If that's my line of best fit without doing a single bit of math, could you tell me what the B was? What's the B? 400. What if this is your line of best fit? Can you tell me what the B is of the green one? What's the B? It's 1200. You can find your B just by looking where your line crosses the y-axis. Now, if you want to do it mathy, you can, but you don't have to. All right, so your homework, let me erase all this because this doesn't go with the problem. Your homework is to make a scatter plot. That's number 1. Draw a line of best fit. That's number 2. And I'm going to put number 3, circle anchor points. And then that's going to lead you to here where you're going to use those anchor points to find your M and your B. Okay. All right. That is it. Thank you very much for your attention. I will see you all tomorrow. For those of you at home, when you're done with the video, go ahead and work the bottom half of the assignment and then email me if you have any questions.